Hello everyone, welcome to the lecture series of pattern classification. I am Kundan Kumar, and if you would like to have these lecture slides, you may refer to my GitHub page at this given link. So in last lecture, we were studying the clustering techniques and we have seen the different types of clustering technique. So now we will be discussing Bachelor and Wilkins algorithm. So this algorithm is a basically heuristic procedure for clustering, which is also called the maximum distance algorithm. So as this is heuristic approach, that means it will not ensure that whatever the clusters we will get, that will be our optimal solution. Okay, so it totally depends on the initial choice of the cluster center. So how this approach works, let us suppose we have set of data samples in the feature space. Okay, so here we are not considering that these are clusters, but visually it shows that it has 3 clusters. Okay, so randomly from these data samples, randomly we will choose one data sample. So suppose x1 we have chosen, and then we will assign it as the first center of the first cluster. So, and it is denoted as Z1. Okay, then we will compute the distance of this cluster. That means the distance of all the data points from this center, that is Z1. Okay, we will compute all the distances. And we will select that data point which is at the maximum distance. So from here you can observe that this x6 is at the maximum distance from this x1, where I have chosen this data sample as center of the first cluster. So the farthest data sample will be chosen as the center of the second cluster. So we are assigning it Z2, which is the center of the second cluster. So this procedure iterate till that how many clusters we want. Okay, so once we will reach the number of clusters, then we will stop, and then based on the Euclidean distance, rest of the data sample will be assigned to different clusters, and there we will compute the Euclidean distance from the center of the clusters. Okay, so this is the concept of the Bachelor's and Wilkins algorithm. Okay, so first we will solve a problem, then we will discuss the exact algorithm. So here the problem is to perform Bachelor and Wilkins algorithm to clusters of the following data samples. So here we have these data samples. Okay, so A to K are the just notation for these data points. Okay, so as previously we have solved many problems, there we have computed the distance, because clustering is totally based on the distance measure, that how the data samples are similar to each other. So in machine learning pattern classification, we have different types of distance measure, but for these algorithms we are computing the Euclidean distance. So for this problem we are computing the distance matrix. That means we are computing the distance between each pair of data samples in the feature space. That means we are computing distance between A and B, we are computing the distance between A and C, A and D, AE, like this. Okay, so we can construct our distance matrix by calculating only the upper half triangle of this matrix, because this matrix is going to be similar, because if this element is the distance between A and B, so this will be also the distance between A and B. Okay, so this will be symmetric matrix, not similar, it will be symmetric matrix. Okay, and the size will be the number of samples by number of samples. Okay, so here, as I discussed that how this algorithm works, so we have to pick up any random data sample and we will assign that data sample as center. Okay, so suppose here randomly I am choosing that A is our the center of the first cluster. So this is the center of the first cluster that I have chosen, and this is totally random. Okay, we can choose other as well. Okay, it is not necessary that the first the data sample will choose. You can choose the random one. Okay, then we will compute the distance, okay, of this center to all the data samples. So here you can see that these are the distance between data sample B and center 1. Okay, so this is the distance between the data point C and the cluster center. So in this way we will compute each distance and we will find that which data sample is at the farthest distance. So here in this row we have to find the maximum value. So here we have maximum value at this location. So it means that the data sample A is at the farthest distance from the data sample data sample H. Okay, so that means H is the center of second cluster. Okay, so now we have two centers. So if we want to stop here, that suppose in our problem it is known to us that how many clusters we need, then and if it is 2, then we can stop here and then we will compute the distance of all the rest of the data samples from these two center points, and based on the minimum distance we will assign to that class. Okay, but we want to go further, then what will be the next cluster center? Okay, so here we have the distance matrix. Okay, the same distance matrix is here. So this is our C1, okay, and H is our C2. Okay, so here C1, C2, so this is A and this is H. Okay, so we will compute the distance of rest of the data sample from these two centers. Okay, so what are the rest of the data points? It is B, C, D, E, F, G. So H is already center, so we will exclude H, I, J and K. Okay, so here we can fill this table using this distance matrix that already we have computed. Okay, so here the distance between A and B is 1.0, distance between B and H, okay, it is 7.8, the distance between A and C, that means basically we have to look at this row and this column. Okay, so here CAC, so AC is 2.2, then CH, this is CH, this is 6.4, then DA, this point, so 2.8. so you can write other values as well. Okay, okay, that means this row. Okay, this row, and for this column we have to look at this column. Okay, so here DH is 5.6, then HE is 1.4, then FH is 1.0, then GH this is also 1.0, then IH, so here this is IH, okay, and JH, so here JH, okay, then KH. Okay, so here we have to choose the third center, which is the maximum of all the minimum. Means in this row, that means this B sample is closest to which cluster? So it is closest to this cluster. Okay, here C is closest to a cluster. So in this way we will mark all the minimum values. Okay, and if the value will be tie, then we can pick up any one, that but we have to fix with it that we can choose the first one. Okay, then this value and this value. So these marked values are basically the minimum distance. Okay, so we have to choose the third cluster, which is the maximum of all minimum distances. So among all these marked values, this is the value which is maximum. So we can choose this one as C3. And C3, how we have chosen? I'm writing here that the third cluster center is the maximum of all minimum distances. Okay, so now we have 3 clusters and 3 centers. So K is our C3. Okay, so A is C1, H is C2 and K is C3. So we have created 3 clusters. Now suppose our aim was to divide the data set in 3 clusters. So now we want to find the cluster data samples. Okay, that means data sample in 3 different clusters. So how we can assign the data samples? Okay, so the same procedure we will do but with the 3 clusters, and we will compute the distance of each data sample from the 3 different clusters, and we will choose the cluster which is closest to the data sample. Okay. So we can create another table. Okay. So here now we have 3 columns because we have 3 centers, and the centers are C1 is A, C2 is H, and C3 is K. Okay. And what are the data samples left? Those are B, C, D, E, F, G, I, and J. Okay. So we can compute the distance. Okay. So from this distance matrix, we can compute here the distance between A and B. So it is 1.0. Here it is distance between B and H. So B and H. So this is 7.8. So in this way, you can fill this table using this distance matrix 8.1. Okay. So you can fill all these values using this distance matrix. Okay. So now we have to assign each data samples to different clusters, and it is totally based on the distance. So you can notice here that B is closest to A. Okay. So the B will be assigned to A cluster. Okay, because it is at the minimum distance. So this row shows the distance of B from cluster C1, C2, and C3. So we have to pick up the minimum distance. So just we can mark it. Okay, it is quite easy. Okay. So you can notice here that these circles and the center form the cluster. So we have the final clusters. It is A, B, C, D, and H, E, F, G, okay, and I, J, and K. So here we have 3 clusters, C1, C2, C3. Okay. So how we obtained the clusters using Bachelor and Wilkins algorithm. So this is the algorithm. Okay. Again, I am repeating this algorithm. Okay. But we got the brief idea. So first we select first cluster center X1, and that is chosen arbitrarily, and we assign it as Z1. Okay. Then determine the pattern sample farthest from X1, which is X6, call it cluster center Z2. So this is X1 and this is X6. Okay, in this diagram. Then we compute the distance from each remaining pattern samples to Z1 and Z2, and then save the minimum distance for each pair of these computations, okay, as we did. Then select the maximum of these minimum distance, okay, and if the distance is appreciably greater than a fraction of the distance Z, Z1, Z2, call the corresponding sample cluster center Z3, otherwise the algorithm is terminated. So this is the exact algorithm which tells us about that where we have to terminate. It is saying that, so if the distance between the two cluster, okay, and that is the Euclidean distance, okay, if this is less than some threshold, okay, then we will stop here. Otherwise, we will proceed for the cluster center 3. Okay. So if this distance from each of the 3 established cluster center to the remaining samples and save the minimum of every group of these clusters, okay, so we have chosen the minimum one, so we saved it, okay. Again, select the maximum of these minimum distance. If this distance is an appreciable fraction of the typical previous maximum distance, the corresponding sample becomes cluster center Z4, otherwise the algorithm is terminated. So this is basically the iterative process, okay. Just you can keep in mind that we compute the next cluster as it satisfy this criteria, okay. So here we have to repeat until the new maximum distance at particular step fails to satisfy the condition for the creation of new cluster center. Then at the end, assign each sample to its nearest cluster center, okay, that we did in the last step, okay. So we formed the 3 different clusters, okay. So this was the Bachelor and Wilkins algorithm. Now we will be discussing the graph-based algorithm, which is the another type of clustering technique where we use graphs to cluster the data samples in feature space. So what is graph? Graph can be represented as the set of vertices and the set of edges, okay, where V is the set of nodes also called vertices and E is the set of edges. So there are many ways to represent a graph, and one of them is the adjacency matrix, which is also called the similarity matrix. So usually if we have n number of nodes in a graph, then the dimension of the similarity matrix will be n cross n, and the element of the similarity matrix will be either 0 or 1. 1 shows that the vertices are connected and 0 shows that vertices are not connected. So let us see one example. Suppose we have a graph, okay. So suppose this is our graph, and in this graph we have 4 nodes and 3 edges, because these are called the nodes, okay. So A, B, C, D. So V is the set of all the vertices, and we can give the name to the edges. So E1, E2, E3. So E is the set of edges E1, E2, E3. Okay. So from this graph, we can create our similarity matrix. So similarity matrix can be defined as, suppose Sij equal to, sometimes we use the notation A as well because it is also called the adjacency matrix. So here we have 4 number of nodes, that means n equal to 4. So the dimensionality of Sij is n cross n. So here it will be 4 cross 4. Okay. So here it will be A, B, C, D, A, B, C and D. And we have to check that which vertices are connected and which vertices are not connected. If it is connected in some sense, okay, then the corresponding value in the similarity matrix, it will be 1. So for this graph here, the vertex A and B is connected. Okay, the vertex A and B are connected, so the value will be 1. Okay, but here B and C are not connected, so the B and C will be 0. Okay, but for the self we don't have any edges. Okay, that means, is there any edges between A and A? Here we don't have any edges, so it will be 0. So do we have the edge between A and C? Yes. Do we have an edge between A and D? Yes. So from B we have one edge to A. This is 0. This is 0. Okay. C to A. Okay. This is 0. This is 0. This is 0. And D to A. This is 1 because we have edge between A and D, but we don't have the edge between D and B. So it will be 0, 0 and 0. So this is our similarity matrix that we can form. Okay. So to understand the different types of clustering based on graph, we should understand the different types of graph as well, like complete graph. What is complete graph? What is tree? What is spanning tree? What is weighted graph? So let me define one by one. So what is complete graph? So if we have the edge between each pair of vertices, then it is called the complete graph. For example, suppose here we have 4 vertices and all the vertices are connected. Okay, so that we can say that it is complete graph. So if we have n is the number of vertices, then here we will have the number of edges, and that will be nc2. Okay, so for this case it will be 6. Okay, the next is tree. Okay, so what is tree? Tree is a connected graph without any cycle. Connected graph means all the nodes should be connected through some path. Okay, there should be a path between each pair of nodes in a graph. So suppose we have this graph. So here, suppose this is a single graph, but from this node, okay, from this node we cannot move to this node because here there is no connection. Okay, so this can be considered as a graph, okay, single graph, but this is disconnected graph. So for the connection, it is must required that there should be a path from between, that means from one node to another node, and that node can be any random node in the tree. Okay, so this is basically the disconnected graph. Okay, so basically tree is a connected graph without any cycle. So if we have something like this, so here see all the vertices are connected through some path. Okay, and here we don't have cycle. So if we will connect these two, then here we have a cycle. Okay, but in this case we don't have any cycle, so tree is a connected graph without any cycle. Okay, the other type of graph is the spanning tree. That means this is basically the type of a tree. Okay, so the spanning tree is a subset of a graph containing all the nodes. Okay, that means subset of a graph containing all nodes and does not contain any cycle, because a graph to be a tree, the condition is that it should not have any cycle. Okay, so suppose we have a graph. So this is graph. Okay, and if we are trying to find a spanning tree from this graph, so the spanning tree is basically subset of this graph. So here, so all the vertices will be present and there should not be any cycle. So this is a spanning tree of this graph G. Okay, so there should not be cycle and all the nodes should be present in the tree. So a spanning tree is the subset of graph containing all the nodes of G. Okay, and it should be connected. Okay, and there should not be cycle. Okay, next type of graph is weighted graph. So any graph where we assign some weight to the edges. That means a graph with weight on its edges. So like suppose we have a graph something like this, and suppose these are the vertices and there is some relation between suppose these two vertices, and this relation may be a distance or some other parameter. So suppose we are defining that the distance between node A and B is 1.0. So it denotes the weight of that edge. Okay, so if we have the weight for each node, the weight for each vertices, then this graph is called the weighted graph. Okay, so in this lecture series we will discuss the two types of clustering algorithm based on graph techniques. The first one is similarity matrix based clustering and the minimal spanning tree based clustering technique. Okay, so let us discuss first the similarity matrix based clustering technique. So we will try to understand this clustering technique with the help of the example. So let us perform the similarity matrix based clustering technique to cluster the following data samples. So these are the same data samples that we have used to solve the previous problem. Okay, so we have total 11 number of data sets in the feature space, and here A to K are the just notation to these feature vector which is in the two-dimensional feature space. So here also we can compute the distance matrix because we are computing the similarity between the two data samples in the feature space based on the similarity, and here we are using the Euclidean distance. Okay, So this distance matrix we can construct where we have used to compute the Euclidean distance between the pair of the data sample. Okay, so so this is the distance, Euclidean distance between the node A and B, and how we can compute it. So this is the two-dimensional feature space. So I'm writing the distance for two-dimensional feature space. So distance between AB is A1 minus B1 square plus A2 minus B2 square, where this is A1, A2, and this is B1, B2. Okay. So this will be 1 minus 1 square plus 1 minus 2 square and then square root. And when we calculate it, it will be 1. Okay, so this is the distance. So in this way, we can construct our distance matrix for this given set of data samples. Okay, so also we have discussed that this distance matrix is basically the symmetric matrix. That means, so to compute the similarity matrix, we can fill these places as well so that it will be easier for us. Okay, so just replicating the values in the lower diagonal elements. Okay, so here all the values are written. So this is the complete distance matrix. Okay, now from this distance matrix we have to compute the similarity matrix based on some criteria. Okay, so suppose in this problem we have given the criteria that d of xi and xj, that is the distance between ith data sample and the jth data sample, is less than equal to 2. So if this criteria will satisfy, then Sij will be equal to 1. Okay, otherwise 0. Okay, that means the two data samples will be considered as connected if the distance between those two data samples will be less than equal to 2. Okay, so based on this criteria we can construct our similarity matrix. Okay, so instead of 2 we can have any other threshold value that depends on us and depends on the different application. So for this problem, let us create our similarity matrix. So this is our distance matrix. So we can create our similarity matrix as, so this is 0, so which is less than 2, so this will be 1. Okay, so here also it is 1, so it will be 1. Okay, here the value is 2.2, which is greater than 2, so it will be 0. Okay, so using this criteria we are constructing our similarity matrix. Okay, so this is our similarity matrix. Now from this similarity matrix we will try to find our clusters. So in this similarity matrix we will pick a data samples, and that data samples we will select randomly. Okay, we can select any data samples. So let us select B. Okay, so suppose B is the random data sample that we have selected, and from that we will create our cluster, okay, based on this similarity. So suppose we are selecting a random data sample B, so we have the cluster with an element with a data sample B. Okay, so we will check here that here what are the other nodes are adjacent to this node B. Okay, so wherever we will find one, that means those nodes are adjacent to B. Okay, so in this case the A, B and C are adjacent to the node B. Okay, so already we have B data sample in our group. Okay, so we can add here A and C. Okay, so here all the adjacent node of B is already in the set. Now we have to check for the node A and C. So here we will check that what are the nodes adjacent to A in this similarity matrix. So this is row for node A, and what are the adjacent nodes? Those are A and B. So A is already in this group and B is also already in this group. Then we need not to add anything. Okay, that means A is also checked. Now we have to check C. So what are the adjacent node of this C node? Okay, so here this is the row for C. Okay, then we will check that what are the adjacent node of this node. So here B, C and D. So in this group B is already there, C is already there, but D is not there, so we will add D. So here we checked all the adjacent node of C, so we will mark it completed. Okay, now in this set again the D is not checked, so we will again check the set. We will check the node D, that what are the adjacent node of D. So the adjacent node of D are C and D. Okay, so this is already in this set, so this is also scanned or this is checked, so that means this group is completed. Okay, so in this group we have 4 number of nodes. Okay, and these nodes are adjacent to each other. That means these nodes having some kind of similarity between each other. Okay, next whatever the left nodes we have, okay, we will pick up the random. Okay, we will pick up one random node from the nodes which are left with us. So let us pick up E. Okay, so suppose this was the cluster 1. Now we are creating the another cluster. Okay, so in this cluster we have selected a random node E. Okay, so now we will list all the adjacent node to E. Okay, so here the nodes which are adjacent to node E are E, F, G, H. So we will add all the nodes in this list or in this group. Okay, so E is already checked. Now we have to check F. Okay, if we will check F, okay, then these are the adjacent node and these nodes are already in this list, so F is also checked. Then we have to check G. Okay, so what are the adjacent node to G? These are the nodes which are adjacent to G, and all these nodes are already in this list. Okay, that means G is also checked. Okay, now we will check H. Then here we can find that the adjacent node to H are E, F, G, H, and all these nodes are already in this group. Okay, and now we don't have any node left which is unchecked. So we will stop here for this cluster, and this cluster will be C2. Okay, now we will check the condition that all nodes are scanned or not. All the nodes are, is there any other row left in the similarity matrix? Yes, we have left. So we will check. So here we have left with 3 nodes. Then we will pick up randomly. Okay, so let us pick the ith node and we will create a new cluster with the node I. Okay, and we will find the adjacent cluster. Okay, adjacent nodes in this similarity matrix. So these are the nodes which are adjacent to I, which are I, J, K. So I is already there. We have to add J and K. Okay. Then here I is checked. Now we have to check J. So here in this similarity matrix, we will check J. Okay. And here these are the adjacent nodes of node J, which are I, J, K, and these nodes are already in this group. So we need not to add any node. So J is also checked. Now we will check K, and here the same nodes I, J, K are adjacent to K, which is already in this group. So now in this group all the nodes are checked. So we will finalize that this is our third cluster. Now we don't have any node left to consider for the clustering. So that means this is our final clustering. Okay, and this clustering is called similarity matrix based clustering. Okay, I hope I'm clear to you. If you have any doubt, you can ask in the comment section. Thank you.